Hey guys, so now that you've watched the 9.1 videos on Canvas, which are brought to you by Cengage, I wanted to do a couple of examples. So there's three ways that we're going to be looking at finding limits. We're either going to be looking at finding limits numerically, which means we're going to be using a table. Graphically, which means that we're just going to look at a graph. That means that we're not going to get an equation or a table or anything like that. And lastly, finding them algebraically. So finding them algebraically means that we actually have to do some sort of math, like factoring or something like that. So first off, we're going to look at numerically. So we want to find the limit of this function. So we have the limit of x squared minus 5x plus 6 divided by x minus 3. And we want to look as x gets really close to 3. So here's an issue that we're going to have is if I just try to plug 3 in, that is going to be 3 minus 3 on the denominator, which equals 0. And if we've learned anything in math, it's that you're not allowed to divide by 0. So what we're going to do is we're going to look at values of x as x gets really close to 3. That's actually the whole reason that we invented limits, is because we're taking something to the limit. So we're taking it as close as we possibly can. So we're going to choose numbers close to 3 and on either side of 3. So here, this is 2.9, 2.99, 2.999. So what we'd say over here is that x is approaching 3, and we're approaching 3 from the left-hand side. So we're getting closer and closer to 3 from the left-hand side. So what we do to denote that we're coming from the left is we put a minus sign. So it's numbers that are less than 3. Over here, we're choosing numbers like 3.01, or sorry, 3.001, 3.01, 3.1. So we're getting closer from the right. So we say x approaches 3. And we use a plus sign when we're talking about from the right. So what we notice is that as our x value gets closer to 3, we want to see if there's a trend in our y values, or f of x values. So as we get closer from this side, it looks like f of x is getting closer to 1. It's getting closer to 1. And as we approach on the right-hand side, so we get closer and closer to 3 coming from the right, it also looks like f of x is getting closer to 1. So what that means is that the answer to this question up here is that the limit, let me erase this, boop, 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 is that the limit is going to equal 1. Great. Notice that we can't actually plug 3 in because if we do, it's undefined. Now, going onto your calculator and doing this over and over and over can be a real pain in the butt. So what I've done is that I've shown you here how to do this on Desmos. So I'm going to switch over to Desmos real quick and just show you how to type all this information in. So if you go to desmos.com and you go to start graphing, the first thing we're going to do is enter our function. You have to enter as f of x equals. So f of x is going to equal x to the second minus 5x plus 6 divided by x minus 3. Alright, now to get that table, what you're going to do is go to the plus and hit table. Now we actually want to change these up here to just a plain x, and we want to change this to a plain f of x. Now what's cool is that we can enter values of x, and it'll tell us exactly what our function value is. So let's say we want to do 2.9, 2.99, 2.999. It'll enter those values for us. Knowing how to do this using a table is very important, because if we zoom in on our function, there's actually a hole here when x equals 3, but there's no hole on the graph, so Desmos doesn't show that to us. However, if we use the table and we try to plug 3 in, it will say undefined. Okay, so that is how you do that on Desmos. So remember, you have to define your function as f of x, and then after you plug the table in, you have to change those headers to a plain x and a plain f of x. Alright, we'll minimize that for now. Let's go ahead and look at the next one. So now what we want to do is find the limits graphically. So again, we don't have a function, but we do have this graph. So remember that when you're looking at a graph, your y-axis is your f of x, and your x-axis is what your x value is. Another thing before you even start looking at these problems is that if you have a solid point, that means that your function is defined there. An open circle means that there's no point there or it's undefined. So, for example, if we were to look at when x equals -2, we would say that f of -2, so if I actually plug -2 into my function, would actually equal, well, y would equal 1/2 or 0.5. Okay. However, if I'm looking at the limit, as I get closer and closer, without actually plugging in -2, what I can see is that the limit looks like it's approaching 1. So let's just go ahead and keep that in mind while we are working through these. It's not necessarily where the function is defined that we're interested in. We're more interested in what does it look like the y value is approaching. Okay, so for the first one, we are going to be looking at when x is -2. And this little negative up in the superscript means it's on the top, so kind of like an exponent, means that we're coming from the right-hand side. Or no, I'm sorry, it does not. It means we're coming from the left-hand side, from over here. So as we're getting closer to -2, what does it look like our y value is getting closer to? Well, it looks like our y value is getting closer to 1. Now if we look at the limit as we approach from the right-hand side, we want to know, hey, what is our y value doing as we get closer from this side? And it is also approaching 1. Now if we want to look at the overall limit of -2, and it doesn't have any of the superscripts, it doesn't have the plus or the minus, well, that limit is only going to exist if the limit on the left-hand side and the right-hand side are the same. So a limit is kind of asking like, hey, what's the final destination as I get closer to this number? And you're only going to have a final destination if they match up. So that would be 1. All right, let's look at as x approaches -1. So we're going to look at when it's approaching from the left-hand side. Okay, so as we approach from the left-hand side, it looks like my y value is getting closer to 3. As I approach from the right-hand side and get closer to -1, well, remember, we have to follow our graph. So as I get closer, this one actually looks like my y is getting closer to -2. So remember, I'm following the graph as it gets closer to the x value -1. Now, if I ask you, hey, what's the overall limit as x approaches -1? Well, they don't have the same meeting place, aka the same destination. So we say the limit does not exist, or D and E. Remember, the limit has to be the same on the left and the right. Now, the limit as x approaches 3, which would be right here, well, this is kind of cool because if we look at the graph, when x is 3, it's actually a solid line, which means that our function is defined. That's really nice because if our function is defined there, then that means that the limit as we approach from the left-hand side and the right-hand side are going to be the same. It looks like they're both going to equal 1. And since they're the same on the left and the right, the overall limit would be 1. All right, the last one would be the limit as we approach 2. So, as we get closer to 2, remember that negative means we're getting closer from the left-hand side. Let's see, it looks like my y value is getting closer to 2. However, as I approach from the right-hand side, and I look at my graph, it looks like I'm getting closer to 3, which means, since these don't match from the left or the right, the overall limit does not exist. Now, just for fun, what is f of 2 actually equal? Well, if we look at either of these points, neither of them are filled in, but 2 is filled in right here. So if I actually plug 2 into my function, I get out a negative 1. Okay, so remember, it doesn't matter where the filled in hole is while we're looking at limits. What we're more interested in was the behavior look like it's approaching. All right, now for the last one, we're going to look at finding limits algebraically. So this is a two-step process. So first, whenever you're trying to do a limit, always just try to plug the number in. So if you plug the number in and then it equals a real number, you are done. That's your answer. However, if you try to plug the limit in and it equals 0 on the bottom, we have to take some more steps, which means that we need to try to factor and cancel. If you are like everybody else on the face of the planet and you're like, oh, I'm not really good at factoring, you can always go to Wolfram Alpha and it'll factor things for you, which is really nice, especially if you just want to brush up. So let's do these together. So in the very first one, we are going to do the limit as x approaches -1, and our function is 4x squared plus 7x minus 12. So remember, the first step is you always want to try to plug it in. So what is 4 times -1 squared plus 7 times -1 minus 12? So let's see, that would be 4 minus 7 minus 12. So let's see, that would give me -19 plus 4, that would give me -15. Hey, since it's equaled a number, we are done. So the limit equals -15. Great. Now, one more thing. This is a polynomial function. Okay, that means it doesn't have a denominator with an x, and also it's just numbers times x to some nice power. If you ever have a polynomial, it's always going to have a limit. You just plug the number in and you're done. Now, this sneaky one, if I plug my x value in, what I'm going to get is 5 squared minus 2 times 5 minus 15 divided by x minus 5. Now, I'm sorry, that's not going to be an x minus 5. Whoops. That's actually going to be 5 minus 5. My bad. So, let's see. On the top, I'm going to have 25 minus 10 minus 15, so that's going to give me a 0 over 0. Uh-oh! What just happened? I have a 0 on the bottom. So what do I need to do? I need to factor and try to cancel. So let's try to factor this. So that would be the limit as x approaches 5. Now let's see, I need two numbers that are going to multiply to 15, and that will add to -2. So let's see, let's do +3 and -5. Yep, that works. All right, great. Now what I see is that these are actually going to cancel. So after those cancel, what I can do is I can just plug the 5 in. So I get 5 plus 3. Great, and that limit equals 8. Awesome. Now factoring and canceling is actually only going to work if you get 0 over 0. So on the next example, if we plug 4 in, what we are going to get is we're going to get 9 over 0. Well, we can't factor this anymore, but what this means is if you get a number over 0, so a number over 0, what that means is that your limit just does not exist. Okay? What this is actually going to give you is it's going to give you some sort of asymptotic behavior. So what that means is if you were actually to draw a graph of this function, as you plug numbers in, it would either shoot down to -infinity or it would shoot up to +infinity. So you'd have a vertical asymptote. So bad news. All right, there you go. There's your quick review of section 9.1. I hope that was helpful. If you have more questions, please don't hesitate to shoot me an email. I'll make some more videos for you.